خليني بس اشوف علي wait a minute بس wait a minute بس بدي اعمل تشيك للاتندنس. This is my morning Nescafe. Do you see it? Okay.
صحتين.
أستاذ وأنا شربت هسه كاكاوي.
Every adult needs a morning cafe.
أستاذ وأنا هسه شربت كاكاوي خلصت.
بدي اشوف who is absent today but just.
أستاذ إحنا كلنا هنا ما عدا واحد على ما أعتقد اللي هو تايم.
كرم.
طيب
هاي تايم فري.
علي ربابعة موجود. اوكي بسرعة كويكلي. هاني
موجود.
غنمة.
Yeah, Mr. Time is here, but Karam is not.
تايم is here. هاي شايف تايم. هلو تايم.
هاي كرم فات.
تايم. Good morning.
Hello,
Hello.
teacher. I just joined.
Karam, good morning Karam.
Good morning.
What teacher?
من اللابتوب ولا من
بشوف I
التليفون؟
want to check بدي اشوف الحضور غياب. لين.
أحمد أشرف الصمادي not here.
طب wait لين.
أستاذ عمل ديسيبل للشات.
استنى شو شباب بالله شوي علي. لين. اوكي ثانك يو. راشد موجود. اوكي كرم موجود. ريان.
ريان موجود.
حاضر. احمد بجوز متاخر. سامي كلارك وينه؟
موجود.
اوكي كيفك يا سامي؟
هلا.
تايم موجود. طيب ادم.
أرسل موجود.
الاس اتش.
دائما في الخدمة.
محمد عزام.
موجود.
هاني غنمة. هاني ليش ما بتحكي يا هاني؟ طيب الآن I think إنه بس just أحمد أشرف I think he is late يعني مش absent maybe يعني دائما هو بتأخر شوي. طيب علي ربابعة can you tell me what is nuclear energy?
Is a type of potential energy that is inside the nucleus of an atom.
Exactly. Thank you very much. It's a type of potential energy that is stored in the nucleus. It is stored in the nucleus of the atom, and for this reason, it is called nuclear energy. طيب, how can we get this energy that is stored in the nucleus of the atom? How do engineers take this energy? Ali, yalla, continue.
By fission or fusion.
By two chemical reactions, fission and fusion. Which is more easier, or which is easier, fission or fusion? Is it easy to make the fusion reaction?
No, because it's need too much
Atoms.
High temperatures, high energy. Okay, what is fission?
Fission is when the
Please, معلش, student, please. No one talks on answers without my permission, please. طيب, Ali, continue.
Fission is one atom that when we separate it to two atoms, we get energy.
Excellent. Fission, look here, look at the cursor. I am pointing on fission. Fission is a nuclear reaction. In this reaction, the nucleus splits, يعني break down or divided into smaller fragments. Okay, like this. This is fission. This is nucleus. It is splitted into smaller fragments. This reaction releases a great amount of energy. طبعا nucleus, what is the plural of nucleus? It is nuclei. Thanks Sami. طيب سامي, what is ليث أو سامي. Okay, I'm sorry. LSH, what is fusion?
Fusion is a type that we have one atom and there is another atom when they are have a summation with each other, we have energy.
Okay, so fusion is another type of nuclear reaction. In fusion, it is exactly the opposite of fission. Small nuclei. It doesn't mean just, it's not only two, maybe 2, 3, 4, whatever. Small.
Fusion?
نعم.
Can I explain fusion? So
Okay, كنت يا راشد again, يلا.
fusion is when all the nuclei form a larger nucleus. So that's the opposite of fission.
Yes,
And
combine.
needs very higher
Yes.
temperature.
يعني in fusion, small nuclei combine to form larger nuclei. In both cases, either
On the other hand, fission loses fragment. Like
ايش ما فهمت عليك راشد احكي.
on the other hand, a nucleus splits into smaller
Yes,
fragments.
of course. In fission, the nucleus is splitted. Okay, like look here. Here in fusion, small nuclei combine to join a large nucleus. Here, in both cases, there is a great amount of energy. Okay, in both cases. Okay, what is wrong with fusion? Fusion takes place, or not? It's not the problem. I mean, but example of fusion happens or takes place where inside the sun. The sunlight or sun energy comes from this reaction. Fusion releases more energy than fission, by the way, but the extremely high temperatures that are required to start fusion reaction make it more difficult to use and control. So the nuclear power plants use the fission reaction, not fusion, because it's very, very difficult to make this reaction, the fusion. Okay, understood? طيب, who's talking now?
Me, Ali.
ايش علي؟
Question. How we can make fission and it's impossible to cut an atom?
استنى شوي، ويت شوي بالله، خليك لاقي. which page هاي؟
110.
110. Where is this question? I don't. 110. Okay. 110. Where is this question?
It's from me.
لا أنت يعني أفكر مكتوب بالكتاب. Again, repeat the question.
How can we make fission and it's impossible to cut an atom?
No, it's not impossible to cut, to split the nucleus, but it needs specific. It's not easy in ordinary tools or equipments. Yani you can't, for example, I can't split the nucleus here in my room, but in the power plants there are many tools or many equipments, and there are specific conditions to split the nucleus. Okay, and this, yani, it's a technique or experiments that we can do this. Okay, but in ordinary conditions, the atom cannot be splitted. Okay, right. Thank you. Good question, Ali. Thank you very much. Yes, this is a very good question. Thank you, Rashid. Do you have any question?
No, Mr.
بس خلص put your hands down. اللي ما عنده, if you don't have any question or any comment, put your hands down. Karam.
Teacher, could you summarize this lesson?
Yes, okay. أنت جيت متأخر يعني?
Yeah, 7 minutes late. I'm sorry.
So we were talking yesterday. We were talking about the mechanical energy. Okay, and nuclear energy. This is a revision for our class yesterday. Mechanical energy is the energy an object has due to its motion, shape, position, or a combination of these factors. Okay? Or simply, you can say that the mechanical energy of an object is the sum of its potential energy and its kinetic energy. Again, mechanical energy is the energy an object has due to its motion, and as if you remember, motion means kinetic energy. Shape or position means potential energy, because the energy that an object has because of its shape is called elastic potential energy. The energy that an object has because of its position is called gravitational potential energy. So the mechanical energy of an object is the energy that an object has because of its motion, shape, position, or a combination of these factors. Or simply, you can say that the mechanical energy of an object is the sum of its potential energy and kinetic energy.
Could you give any examples of mechanical energy?
Yes, of course. طيب, look here. Karam, you have to know that sometimes the mechanical energy of an object is simply all of its kinetic energy. If, for example, this is ME is mechanical energy, PE physical education or potential energy, what do you think? PE is the potential energy and KE is kinetic energy.
Kinetic energy.
Suppose that the object has no potential energy, zero. So, and has, for example, 20 joules as kinetic energy. In this case, the mechanical energy of the object is what? 20. So, in this example, all of the mechanical energy of an object is simply its kinetic energy. Okay? Right. Example of mechanical energy, a flying bird. A bird that is flying.
Mister, tell you why it has mechanical energy?
What?
Because of the height,
Yes,
the
of
height,
course.
the potential
Look,
energy,
look.
and the motion at the same time.
Okay, I will give you example. For example, suppose that you are running or jumping, okay, on at the or at level 4, at level 5 of a building. Understood? Suppose that you are jumping at level 5 of a building. Do you think that you have kinetic energy in this case?
Yes, of
Why?
course.
Yes, why?
Because of mass and height.
No, you have kinetic energy in this case because you are jumping. You are in motion.
Yeah, in motion, and you have potential energy because you're at height.
Rashid, wait a minute. Suppose in this case, your kinetic energy, for example, 50 joules. Just as an example. طيب. Karam, do you think that when you are at level 5, you have potential energy?
Oh, no.
Of course you have potential energy or gravitational
You have
potential because of
you're
your
at
height, your vertical
yeah,
distance. نعم.
Yeah, because you're at height, and at this moment you have
Excellent.
a gravitational potential energy.
Because of your position above the ground, level 5, so you have potential energy. Suppose that, imagine, or that this potential energy equals 60 joules. So in this case, your mechanical energy equals your potential energy, kinetic energy was 50 plus your potential energy, which is 60, which is equal to 110 joules. In this example, your mechanical energy is the sum of your potential energy and kinetic energy. طيب. Let's take another example. In this case here, in this example, is different from the previous example. Look. Okay. This is, suppose that this is at the top of the hill, there is a stone. Type. Can anyone tell me what type of energy now this stone has?
Potential.
Yes.
Potential.
In this case, or at this moment, when the rock or the stone is at the top of the hill and not moving, it has potential energy or gravitational potential energy because of its vertical distance above the ground, because of its height above the ground. Clear? Right. But the stone,
Yes.
the stone now it's not moving, so its kinetic energy is
Zero.
almost zero or no kinetic energy. Clear? Right.
Yeah.
Imagine that the potential energy or the gravitational potential energy of the stone at this case or in this position is 220 joules. So if we want to calculate the mechanical energy of this object or this stone, it will be equal to 0. The kinetic energy is 0 plus the potential
20
energy,
joules.
which is what? 20 joules.
20 joules.
So its mechanical energy is 20 joules. So according to the definition of the mechanical energy, the mechanical energy in this case, in this example, is equal to what? Only its potential energy, because the stone has no kinetic energy. Okay? So sometimes, look here, back to the definition, the mechanical energy of an object sometimes due to its motion only, sometimes due to its shape or position only, sometimes due to both of them. Is the definition clear now? Okay, look here. The mechanical energy of an object is sometimes due to its motion only, or its kinetic energy. Okay, motion means kinetic energy. Sometimes the mechanical energy of the object is only because of its shape or position, or because of its potential energy. Sometimes both of them. يعني I mean, or in other words, look, you can understand this by think of this topic subject but mathematically, by math. If the kinetic energy is 0, so all of the mechanical energy will be potential energy. If the object has no potential energy, so all of its mechanical energy will be kinetic energy. But if the object has both of them, so the mechanical energy will be the summation of them. Or you can, if you want to understand the mechanical energy, just remember this equation. Mechanical energy equals potential energy plus kinetic energy. If the potential energy is 0, so all of the mechanical energy will be kinetic. If the kinetic energy is 0, all of the mechanical energy will be potential. أعيد ولا فاهمين؟
أنا فاهم.
وأنا كمان فاهم.
طب okay. The nuclear energy simply is the energy that is associated or is a stored energy or potential energy. Nuclear energy is a type of potential energy that is stored inside the nucleus of the atom. This energy can be released by using nuclear reactions. There are 2 nuclear reactions, fission and fusion. Fission, this chemical reaction in fission the nucleus of the atom splits or divided or break down into smaller fragments or to many nuclei. This process releases energy or a great amount of energy, and this reaction can be done or takes place where in the nuclear power plants. Ahmed Ashraf, good morning. انت هون؟
Morning, teacher. I'm here.
طيب. يعني this is a quick revision for our class yesterday. Okay, the another type or the second type of nuclear reactions is the fusion. Fusion is the opposite of fission. In fusion, small nuclei or many nuclei combine to form larger nuclei. This reaction takes place in the sun naturally. This reaction happens naturally in the sun and produces sun energy or sunlight. Sunlight or sun energy comes from this reaction, and it is because this reaction releases a great amount of energy, but it needs high temperatures. Okay, the high temperatures that are required to start a fusion make it more difficult to use and control. So it's very difficult to make a fusion in the nuclear power plants. Now, the third type of energy that we will learn is the thermal energy. And we were talking about this type of energy in the previous lessons and in grade 5, okay, and in grade 4. Thermal energy is the total potential and kinetic energy of not the object, its particles. Or simply, you can say that thermal energy is the total. I think that's Shabab. I think that this definition is not accurate or not correct. The thermal energy is the total. Okay.
Mr. But now,
Okay.
what's the difference between thermal energy and mechanical energy?
Okay, Rashid. The total, not potential. Thermal energy is the total kinetic energy of particles in an object. Yeah, Rashid, this energy is the total kinetic energy of the particles in an object. Look here. You have to know that all matter is made up of particles. Okay? Even the matter is solid, okay? Solid or liquid or gas. Okay, again, all matter, everything around us, the wall, the air, water, even your body is made up of what? Particles. These particles are very, very small. Like particles means atoms. Particles means atoms. These particles are always what? In motion. Do you remember in the previous lesson? All particles of matter, solid, liquid, or gases are always in motion. For example, in solid, they vibrate in place. Type, I want to hear.
Wait, closely tied.
Yes. Look, I don't now. I don't want to talk about how they are arranged, but I want to remind you that particles. شباب انتوا فاهمين؟ Particles of solid.
يعني.
Particles of solid are always moving. They just vibrate in a place. What is the meaning that they are vibrate? They go back and forth in the same. أي كرم. نعم كرم.
Could you right now I don't really understand motion.
You don't or you understand?
Could you just explain the meaning of motion a bit more?
طيب. Repeat your question, Karam.
Could you explain motion a bit more?
Look here. All matter is made up of particles. Particles, we mean by particles the atoms. If the matter is solid, either it's solid, liquid, or gas, it's made up of particles. These particles are always in motion. For example, particles of solid vibrate in place. They go back and forth in their places, but they are in motion. Particles of liquid are also moving. Okay, they slide past each other. If you remember, we said that when you put, suppose that you have marbles in your hand and you are moving them like this. Particles of liquid slide past each other. Particles of gas are always in motion. They move very quickly, okay, in all directions. طيب. Thermal energy is the total, since the particles of matter is moving, the particles are moving, they are in motion, so they have what? Kinetic energy. The total kinetic energy of these particles are called thermal energy. If the particles are moving faster, so their kinetic energy are increasing, so they have more thermal energy. Okay, طيب. Thermal energy is the total kinetic energy of particles in an object. طيب. Lots of particle movement means lots of kinetic energy. So if the object, or if the particles are moving, if we have more particles in an object, so we have more kinetic energy. Lots of particle movement means lots of kinetic energy. The faster the object moves, the more kinetic energy they have, and that means a high temperature. So thermal energy is related to temperature. The more the object, if the temperature is high, the thermal energy is high. For example, hot water has more thermal energy than cold water. Okay, so think of a pot of boiling water. The particles are moving very quickly. When the temperature increases, the particles move very quickly, which means more kinetic energy, and more kinetic energy means more thermal energy, which results in a high temperature. Okay, when the water is boiling, the particles moving very quickly, that means high temperature, and this means the water has a lot of thermal energy. So thermal energy is related directly to the temperature. Understood? High temperature means what? High temperature means high thermal
Kinetic
energy.
energy,
Yes.
which means high thermal energy.
Okay. Low temperatures means low thermal energy. Okay. So any object at higher temperatures, any object at higher temperatures, its particles are moving fast. It has high thermal energy. Yani cold water has less or more thermal energy than hot water.
Less.
Less thermal energy than hot water.
Hot water.
Okay?
Okay, I
So
understand.
thermal energy is directly related to temperature. Look, okay? Look here. Higher temperatures means that objects moving faster, so they have higher thermal energy. Okay, طيب. We have just 5 minutes or less. Why there is no interaction? Why is there no interaction between يعني some students they do not interact with me in the class. طيب, okay. This means that water has a lot of thermal energy when it is boiling. If the water is then put in the freezer, okay, what will happen to the kinetic energy? It will decrease. If the kinetic energy decreases,
and the temperature will decrease.
when its kinetic energy decreases, its thermal energy and temperature also decreases. يعني, okay, you have to, these three things are related to each other. Kinetic energy of the particles, okay, temperature, and what? And thermal energy, they are related to each other. They are directly proportional, by the way. If this increases, and this will increase, and this will increase. Okay? And if one of them decreases, this will decrease, and this will decrease. Okay. So if you put an object, water or whatever, in the freezer, its kinetic energy will decrease, and thermal energy and temperature also decreases. طيب. Now, the transfer of energy into the thermal energy of an object is called heat. Okay, you have to distinguish between heat and thermal energy. Heat,
أستاذ مش فاهم كيف الثيرمال إنرجي متوافق مع التمبرتشر والكينيتيك إنرجي. مش يعني الكينيتيك إنرجي كيف متوافق مع الثيرمال والتمبرتشر.
يعني ليث. Look here. Thermal energy is the total what? Kinetic energy of particles in an object. If the particles have a lot of kinetic energy, so that means the temperature. Look, lots of particle movement, the motion means kinetic energy. Lots of particle movement means lots of kinetic energy. So that means high temperature. When the particles are moving very quickly, very, very quickly, their kinetic energy increases and the temperature increases. When the temperature increases, that means thermal energy increases. Example, boiling water. The particles in boiling water are moving very, very quickly. Okay, particles are moving very quickly, and this is the result in high temperature. This means water has a lot of thermal energy. Okay, the opposite is true. If the water is in a freezer, the particles will move slowly, so their kinetic energy will decrease and the temperature will decrease. That means thermal energy will decrease. Okay, clear?
Can I say something?
طيب علي يلا أجي.
The gas have more thermal energy than the liquid and the solid.
Excellent. والله كنت بدي أحكيها الآن. Yes, Ali, thank you very much. I want to say that you have to know that gas.
بتحرك كثير يا أستاذ.
نعم.
لأنه بتحرك كثير.
Gases or the matter in its gaseous states, when the matter is in the gas state, the particles has more thermal energy than when it is liquid, and when it is liquid, it has more thermal energy than when it is solid. So particles in solid have less thermal energy than liquid, and particles in liquid have less thermal energy than gas, or we can say that particles in the gas state have the most thermal energy, and in solid, because they are not moving very fast in solid.